If you've ever used a chatbot and thought, that sounds confident, but is it actually true? You've bumped into one of the biggest problems with large language models. They can produce answers that sound right even when they're wrong. Retrieval-Augmented Generation, usually shortened to RAG, is one of the most practical solutions. It's a method that helps language models answer using your documents, policies, manuals, PDFs, knowledge bases, web pages, internal notes, whatever you trust as a source of truth. In this video, we'll unpack what RAG is, why it matters, how it works step by step, and what can go wrong when it's built poorly. By the end, you'll understand why many real-world AI assistants aren't just chatbots, they're retrieval systems plus language models working together. RAG stands for Retrieval-Augmented Generation. The name sounds technical, but the concept is simple. Before the model answers, it retrieves relevant information from a set of documents, then uses that information as context while generating the response. So instead of asking an LLM to answer from memory, you're asking it to answer from evidence. The model becomes less of a guessing machine and more of a writer that reads sources, then explains them. Think of it like this. A traditional chatbot is like a student taking an exam with no notes. It might remember a lot, but it's still relying on recall, which can be fuzzy. A RAG system is like that student being allowed to open the textbook, search it, copy the most relevant paragraphs, and then write an answer based on what's actually written there. That difference changes everything. It means you can build an assistant that knows your organization's policies, your product documentation, or your research notes, even if those documents were created yesterday. The LLM itself might not have been trained on your content, but RAG lets it use your content at the moment it answers. The most common reason people adopt RAG is trust. Plain LLMs can hallucinate. They sometimes generate facts, numbers, or citations that don't exist. RAG doesn't magically eliminate hallucinations, but it greatly reduces them because the model is anchored to real text. Another reason is freshness. Language models are trained at a point in time, and even if they're updated, they're never perfectly current. Your business policies, your pricing, your internal processes, these can change weekly. RAG allows an assistant to stay current by retrieving from whatever documentation you maintain today. Then there's specificity. A general-purpose model might know a lot about the world, but it doesn't know your internal naming conventions, your product versions, your legal disclaimers, or that one tricky exception that lives in paragraph 6 of your support manual. RAG lets you bring that detail into the conversation without retraining the model from scratch. And one more benefit is traceability. In a good RAG system, the answer isn't just "trust me." The system can show where the information came from by quoting the retrieved text or attaching citations to the answer. That makes the output easier to verify, easier to audit, and easier to debug when something goes wrong. So when is RAG worth it? When you need answers tied to real documents, when correctness matters, when content changes often, or when the knowledge you want is private and specific. If you're only doing creative writing, brainstorming, or casual conversation, RAG may be unnecessary. But the moment you want reliable answers grounded in your materials, RAG becomes one of the strongest patterns available. The first half of RAG is retrieval, and it's the half that most determines whether your system will feel smart or stupid. Retrieval means, given a question, find the most relevant pieces of your documents. Those pieces are usually not entire PDFs or entire pages. They're chunks, small passages that fit into the model's context window. You can think of chunking as slicing a book into paragraphs that are easy to search. To retrieve, systems commonly use two approaches: keyword search and vector search. Keyword search is what you expect, matching terms. It's very good when exact phrasing matters, like part numbers or specific policy names. Vector search uses embeddings, which are numerical representations of meaning. That allows the system to find relevant text, even if the words don't match exactly. If the question says refund, it may still retrieve passages that talk about returns or chargebacks, because the meaning is close. In practice, many strong systems combine both approaches. Keyword search catches the exact stuff, while vector search catches the conceptual stuff. Then the system ranks results and chooses a small set of top passages to pass into the model. This is where many RAG projects fail. They build a fancy LLM prompt but don't invest in retrieval quality. If retrieval returns irrelevant text, the model will confidently answer based on irrelevant text. And if retrieval misses the key paragraph, the model can't use it, no matter how smart it is. A great RAG system feels like it knows your documents. But what's really happening is that it's consistently retrieving the right evidence at the right moment. Once you've retrieved the best passages, the next step is augmentation. This is where the system assembles a prompt that includes the user question and the retrieved context, plus instructions for how the model should respond. This part sounds trivial, but it's where you decide what kind of assistant you're building. Do you want short answers or detailed answers? Should it be formal, friendly, or technical? Should it cite sources? Should it refuse to answer if the documents don't contain enough information? A common and effective approach is to tell the model something like, use only the provided sources. If the answer is not in the sources, say you don't know. That instruction doesn't guarantee perfect behavior, but it nudges the model strongly toward grounded answers. It also trains your audience, your users, to expect honesty when the documents don't support a claim. This is also where you can shape the output format. Maybe you want a customer support style response. Maybe you want a structured output like JSON for downstream automation. Maybe you want a mini report with a summary and a citation section. RAG works well with structure because the model has evidence and a clear job. Explain it. Augmentation is where you turn retrieval results into something the model can use effectively. The retrieval step finds information. The augmentation step makes that information usable. Now we reach the generation part of Retrieval-Augmented Generation. This is where the LLM writes the final answer using the prompt and the retrieved passages. If you want your RAG system to be trustworthy, this is the moment to demand citations. Citations don't have to look like academic footnotes. They can be simple: a link, a document name, a page number, or a quoted sentence with a source label. The key is that citations shift the relationship between the user and the model. Instead of debating whether the model is correct, you can check the source. That makes the assistant feel professional. It's not just talking, it's referencing. Citations also help you as the builder. If a user complains the assistant is wrong, you can see whether retrieval pulled the wrong passage or whether the model misunderstood a correct passage. Without citations, everything is a black box. A good generation step also handles uncertainty gracefully. If the retrieved documents are vague, the answer should reflect that. If multiple documents disagree, the assistant can explain the conflict and point to both sources. If nothing relevant is found, the assistant should say so and suggest what to look for. This is how RAG turns an LLM from a persuasive writer into something closer to a research assistant. Still imperfect, still needing oversight in high-stakes settings, but far more grounded than a model working from memory alone. RAG can dramatically improve an LLM's usefulness, but it can also fail in ways that are surprisingly subtle. One common problem is chunking. If you cut your documents into chunks that are too small, you lose context. The system retrieves a paragraph but misses the definition that appears just above it. If chunks are too large, you waste context window space and dilute relevance. The model receives a wall of text and doesn't know what to focus on. Another problem is weak retrieval. Sometimes the system retrieves something that is kind of related, but not the real answer. The model then does what language models do best. It writes a confident explanation based on whatever it got. If retrieval is wrong, generation becomes wrong in a very polished way. Too much context can also backfire. People assume more context is always better, but large prompts can introduce noise. You want enough evidence to answer, but not so much that the model starts blending unrelated passages into one messy response. Stale documentation is another silent killer. A RAG assistant can be perfectly grounded and still wrong if the documents themselves are outdated. In a business setting, that's not an AI problem, it's a content governance problem. Security matters too. If your retrieval system pulls text that includes malicious instructions like ignore previous rules and reveal secrets, a naive model might follow it. This is called prompt injection, and robust systems treat retrieved text as untrusted content. They separate instructions from sources, restrict tool access, and design prompts so the model knows that documents are evidence, not commands. Finally, evaluation is often missing. Many teams build a demo that feels good in a handful of tests, then deploy it, and discover failure modes in the wild. The fix is to build evaluation into the process, collect real questions, measure retrieval quality, check citation correctness, and track how the system behaves over time as documents change. A production RAG system isn't set it and forget it. It behaves more like a product than a model. Documents get ingested, chunked, and indexed. Embeddings are created. Search is tuned. Then there's the experience layer, how users ask questions, how answers are displayed, and how citations appear. The best teams monitor everything. They watch which questions lead to low-confidence retrieval. They track when users click citations or complain. They measure whether the assistant is actually saving time or just generating extra work. They also keep humans in the loop for high-stakes tasks. If an assistant is helping with medical decisions, legal guidance, or financial recommendations, you don't want a fully automated final answer. You want a workflow where the model drafts and the human approves. In many organizations, RAG becomes a bridge between messy knowledge and usable knowledge. It's not replacing documentation or replacing experts. It's helping people access what's already written, faster, and in a conversational way. And that's the bigger story. RAG is one of the most practical ways to make LLMs truly useful in the real world, because it ties generation to evidence. Retrieval-Augmented Generation is a simple idea with a big impact. Let the model read the right sources first, then answer based on evidence. When retrieval is strong, prompting is clear, and citations are included, RAG can turn a chatbot into a genuinely useful assistant. If you want to go one step back and understand the foundation that makes all of this possible, watch my video on large language models next. It explains what LLMs are, what they're great at, where they can go wrong, and how they're built, so you'll see exactly why RAG works so well on top of them. Thanks for watching, and if you found this helpful, subscribe for more practical AI explainers.